Hi, math lovers. Welcome to notes number 49, combinations of functions. After all the graphing that we did the last couple days, I think you're going to really like today's lesson. Today we've got functions, and we're going to go ahead and we're going to do all of the operations that we love to do. Addition, subtraction, multiplication, division, and even get functions of functions. So lots of fun for us. We're going to dive right in, and I have an example of two functions. I'm going to say the first function, f of x, we're going to say that's equal to x squared. And the second function we're going to use is g of x, and that's equal to 4x minus 5. Okay, so we're going to do an example of each of these. The first function we're going to use is, what if you want to add functions together, okay? What if they say, hey, take f and g and add them together, and the variable you're going to use is x. This is not times x. It's saying take function g and function f and add them together and use the variable x. So what you're going to do is take the function f of x and add it to g of x. So in my example here, we'll take the function x, f of x, which is x squared, and we're going to add it to g of x. So it's 4x minus 5. I can't go any further, so I'm done. Isn't that great? I've got think about subtraction. F minus g of x. Well, let's see, if I want to take two functions and subtract them, all I'm going to do is go ahead and take f of x, which is x squared, and then subtract g of x, which is 4x minus 5. Well, I should clean that up a little bit. Let's make that x squared minus 4x plus 5. All right, that's it. Multiplication, same kind of thing. If I take the functions and I multiply them together using the variable x, all I'm going to do is take f of x and g of x and multiply them together. So I have x squared times 4x plus minus 5. I'm going to go ahead and clean that up, make that 4x cubed minus 5x squared. Okay? So far, so good. Now let's get to division. Anytime we work with division, remember we've got to think about that denominator not equaling 0. So let's go ahead and divide the f and the g function, and we're going to just put them on over the top of the other, x squared over 4x minus 5. Notice my function of g of x is not equal to 0, so I'm good to go. All right? So let's dive in with compositions of functions. So this is not fog. Kids always want to call it fog, and they always want to call it golf. It's a little tiny 0. No, I shouldn't say 0. A little tiny o. It's not the letter z. It's not the number 0. It's not the letter o. But what it is it's saying take the composition of it. Let's find g of x first on the inside, and then take your answer and put it into the f function. So if you're thinking about it, and you know how I love to draw my function machine, right? So what I'm going to do is I'm going to have some function on the inside. Let's call it g of x. So some number x, I'm going to put that in, and it's going to come out, and then it's going to go right into another function. Oh, this is a funny looking function machine. I need some more practice. So the number is going to go into the g of x function, and then it's going to pop out, and it's going to go right into the f of x function. So the number that's going to come out at the end would be f of g of x. Okay? Little visual for you there. Little visual. Okay. So what we'll do is we'll start at the g of x function. Our g of x function is 4x minus 5. So let's take f of 4x minus 5. Now everywhere in the f function that we had the variable x, I'm going to replace it with 4x minus 5. So that becomes 4x minus 5, the quantity squared. All right? And you know right away, if you want to write that out twice, then you can go ahead and FOIL. Otherwise, you can just look at it and know it's going to be 16x squared minus 40x plus 25. Okay? So I started on the inside g of x, and then I put it into the f function. Notice that now in the second one, g of f of x, we're going to start inside on the f function. So we're going to have g of f function is x squared. So in the g function, everywhere I have an x, I'm going to replace it with x squared. So 4x squared minus 5. Isn't that wonderful? Wow. Okay, so we have all of the functions we're using, all right, all of the rules, and then we have an example of each. Let's try one more. Okay, Let me zoom down here. This one is number 39 from your textbook. Okay. It's saying let f of x be equal to the cube root of x minus 1. And let's let g of x equal x cubed plus 1. Okay. They look interesting, don't they? Kind of opposite of each other, but we'll leave that for another day. All right, my first one, letter A, they say find f of g of x. Okay. You can call it fog if you want, but it's not mathematical. So f of g of x. So I'm going to start on the inside. I'm going to start on the inside here, and I'm going to put my g of x into that. So I've got f of x cubed plus 1. Now, everywhere in the f function, I have an x. I'm going to replace it with this value. So I've got the cube root of, all right, and this is where I would have my x. I'm going to say x cubed plus 1, and then minus the minus 1 from up here. Well, that's really nice, isn't it? Because isn't that just going to be the cube root of x cubed, which the principal root, therefore, would be just plain old x, which would be x. That's nice. Let's try another one. Let's do letter B. Letter B, they say g of f of x, or as the kids say, golf. All right, I like to rewrite it this way first every single time. Now I'm going to start on the inside with the f function. So I'm going to say g of, and I'm going to replace x with the cube root of x minus 1. All right. I'm going to take this value and substitute it in here for my x. So that would be, all right, I've got my cube, right, plus 1. That's the g function. Now in the place of the x, I'm going to put in the cube root of x minus 1. Oh, that's nice, isn't it? Look at that. If I take that and I cube it, I get x minus 1, and then, of course, plus 1, which is just plain old x. One would say that f of x and g of x undo each other. We'll call those inverses tomorrow. We'll formally call them inverses. Let's do one more. Let's do g of x. Oh, this looks like so much fun. Okay, g of x. Okay, or GOG, I guess you could call it. So g of x. Okay, let's start on the inside here, and we have g of x cubed plus 1. Okay, now I'm going to take that g function cubed plus 1. And in the place of x, I'm going to write in x cubed plus 1. Oh, interesting. Okay, so I've got to cube this. I'm thinking Pascal's triangle. You thinking Pascal's triangle, cube? Pascal's triangle, remember 1, 2, 1, 1, or maybe this is new for you. This will formally be our chapter 11. So what you do is you take your power. This is row 1. This is row 0, 1, 2, 3. These are your coefficients for a cube. So my coefficients, if I were to go ahead to write this out, would be 1, 3, 3, 1. And I'm going to multiply my powers. So this would be x to the 9th plus x to the 6th. And I'm going to descend by 3's, x to the 3rd plus 1. And then, of course, this plus 1 at here. Okay. If you didn't want to do Pascal's triangle, you could go ahead and FOIL this out 3 times. That would be fine, and you get the same exact answer. But because I don't want to make your videos so long, I'm going to pull out my shortcut. Plus, what mathematician does not love a good shortcut? Okay. So notice that g of x would give me x to the 9th plus 3x to the 6th plus 3x to the 3rd plus 2. That's a nice problem. Okay. So remember what you learned today. You are working with all of the different functions. We're going to add them, subtract them, multiply them, divide them, and then we're going to do compositions of functions. Lots of great practice for you today in your problem set. Have fun, kids.